To find the dimension of torque, we have to compare between the force and torque. We have to compare between the force and the torque. Force and torque. Force F is equal to m into a, that is the product between mass and acceleration. This is a body of mass m on which a force F is acted, and the body will be moving with the linear acceleration a. Hence we can say that due to application of force, the body will move or will have tangential acceleration or linear acceleration. Due to application of force, the body will have linear acceleration and gets linear motion, gets linearly displacement, or gets linearly displaced. On the right hand side, we can explain what is torque. And here on the left hand side, force is equal to mass into acceleration. This is a body on which a force is acted. This is a body, and O is the fixed point about which the body will rotate or will have a tendency to rotate. O is the fixed point, and a force F will be acted on the body to rotate the body. Along this line of action of force, a force F will be acted. A force F is acted along this imaginary line, along the imaginary line AB, a force F is acted. F is the force which is acted along this imaginary line AB. And we can draw the perpendicular distance of fixed point from line of action of force. ON is the perpendicular distance, and we can denote the distance, oblique distance of the fixed point O from the line of action of force, that is OP, which is equal to R, and theta is the angle between the oblique distance R and line of action of force extended in backward direction. And due to application of this force, the body will rotate anti-clockwise about the fixed point O. The body will rotate. Due to application of this force on this body having fixed point O, the body will rotate anti-clockwise. About the fixed point O. For torque is equal to the perpendicular distance of line of action of force from the fixed point. Torque is equal to perpendicular distance into force. Torque is numerically equal to the product of perpendicular distance and force. Torque is equal to perpendicular distance of fixed point from line of action of force. Torque is equal to the product of perpendicular distance of fixed point O from the line AB of action of force and force. Therefore, tau is equal to ON into F. ON is the perpendicular distance of fixed point from line of action of force, and F is the force. Therefore, torque tau is equal to R sin theta into F. Torque tau is equal to R sin theta into F. Since sin theta is equal to perpendicular ON divided by hypotenuse OP. Therefore, torque tau is equal to RF sin theta. We get torque as R sin theta F or RF sin theta. O is the fixed point of this body. And a force is acted along the line of action AB. AB is the line of action of the force, and R is the oblique distance of the line of action of force from the fixed point. That means oblique distance R is OP, and this angle theta is the angle subtended by oblique distance R with the line of action of force F extended in backward direction. And we get tau as r sine theta F. We get tau as r sine theta F, which is the torque acting on the body, Tau is equal to r sine theta F, which is the torque acting on the body, which rotates the body rotates anti-clockwise about the fixed point O. Here r sine theta is equal ON. R sine theta is equal ON. R sine theta is ON, which is the perpendicular distance of line of action of force, that is AB, from the fixed point O. R sine theta is equal to ON, which is the perpendicular distance of the line of action of force AB from the fixed point. R sine theta is equal to ON is the perpendicular distance of the fixed point O from the line of action, from the line under bracket AB of action of the force F. This is the perpendicular distance of fixed point O from the line AB of action of force F. Now we can find the dimension. We can write down the dimension of force. That means dimension of F is equal to ml t to the power minus 2. That is the dimension of force. On the right hand side, we can find the dimension of torque. Dimension of torque tau is equal to dimension of r into dimension of sine theta into dimension of force F is equal to dimension of L into 1, because dimension of sine theta is 1, which is dimensionless, and dimension of force F is ml t to the power minus 2. Finally, we get the dimension of torque tau as ml square t to the power minus 2. ml square t to the power minus 2. That is the dimensional formula of torque. Dimension of tau, which is ml square t to the power minus 2, which is the dimension of torque, due to application of torque, a body will have a rotational motion. On the left hand side, dimension of force F is ml t to the power minus 2. That is the dimension of force. Dimension of force. There is an alternative process to find the dimension of torque, that means OLITAR. This is a circular orbit along which a body will be revolving. O is the center of the circular orbit. And R is the radius of the circular orbit. And a body of mass m is revolving in this circular orbit with a certain linear velocity. This is a body at the point A at instant t is equal 0 second. At the point A, the body has initial velocity u, and this initial velocity u is also known as linear velocity or linear initial velocity or tangential velocity. U is the initial velocity or tangential velocity. Body is revolving anticlockwise in this horizontal circular orbit. That's why initial angular velocity omega 1 will be directed vertically upwards. That means omega 1 is the initial angular velocity of the body revolving anticlockwise. Alpha is the angular acceleration. Uniform angular acceleration is alpha, and the body reaches to the point B after time t equal t second. This is the final position of the body at the point B. The body comes at the point B at instant t equal t second. The body revolves anti-clockwise in this horizontal circular orbit. Theta is the angular displacement of the body if the body moves from the point A to B. At the point B, final tangential velocity will be v, at the point B at instant t equal t second. V is the final tangential velocity, and now we can denote tangential acceleration as A. A is the tangential acceleration at the point B, and at the point B, now omega 2 is the final angular velocity which is acting upwards at the point B at instant t equal t second. Alpha is the uniform angular acceleration of the body revolving in anti-clockwise direction in the horizontal circular orbit, and also you can denote the torque tau acting on the body, and here the torque tau is acting vertically upwards provided the body revolves anti-clockwise in horizontal circular orbit. On the left hand side, force is again the product of mass and acceleration. F is equal to ma. Here force F is equal to ma. Here force F is equal to ma. This is the force acted on the body, and due to application of force the body will be moving linearly, or the body will have linear motion. F is equal to ma, which is the force acting on the body of mass m, acting on the body of mass m, moving with uniform acceleration, moving with linear acceleration, or moving with tangential acceleration A. F is equal to ma, which is the force acting on a body of mass m, moving with linear acceleration A. On the right hand side, torque tau is the product of I and alpha. Torque is the product of moment of inertia I and angular acceleration alpha. Tau is equal to I alpha, which is the torque acting on the body revolving anti-clockwise direction in horizontal circular orbit. Tau is equal to I alpha, which is the torque acting on the body, which is the torque acting on the body of moment of inertia I, of moment of inertia I, moment of inertia I. Now alpha is the angular acceleration of the body revolving anti-clockwise direction. Alpha is the angular acceleration of the body. Alpha is the angular acceleration. Here force F is comparable to torque tau, mass m is comparable to moment of inertia I, and tangential acceleration A is comparable to angular acceleration alpha. As force is equal to ma, that's why torque tau will be equal to I alpha. Again on the left hand side, we can write down the dimension of force as ml t to the power minus 2. ml t to the power minus 2. On the right hand side, we can find the torque tau by using the equation tau equal I alpha. Dimension of tau or torque is equal to dimension of I or moment of inertia into dimension of alpha, means dimension of angular acceleration, is equal to ml square into, and dimension of alpha is t to the power minus 2. Finally, we get the dimension of torque tau as equal ml square t to the power minus 2. ml square t to the power minus 2. Tau equal, dimension of tau equal ml square t to the power minus 2, which is the dimensional formula of torque, Tau is equal to ml square t to the power minus 2, which is the dimension of torque.